So today in this session, we will discuss about min-max normalization. Normalization is also known as feature scaling. It is a crucial pre-processing step in machine learning and data analysis. It involves transforming the features of a dataset to a common scale or range. Here is the reason why we need to do normalization on features. Because we need to do normalization on features to avoid the bias. Many machine learning models are sensitive to the scale of the input features. If the features have different scales, the algorithm may assume disproportionate importance to features with a large scale, leading to the biased result. Normalizing the features ensures that they are on a similar scale, preventing such bias. So let's consider these two features in a dataset. Suppose if your dataset consisting of these three features, temperature, humidity, and pressure. If you observe here, these temperature values are 15, 20, 35, 30, 25. These are smaller values. Also humidity. These are also smaller values compared to these pressure values. These are 1012, 1014, and 1010. So when you upload this data to a machine learning model, it is disproportionate and gives more importance to the pressure value because it has maximum values. That means larger values compared to the temperature and humidity. So to avoid this, we need to make them into a similar scale. So for that, we need to do a normalization on this data set. So let's apply min-max normalization on this data set. So for applying min-max normalizations, we need to use a formula. In min-max normalization, we use x normalized is equal to x minus x minimum by x maximum minus x minimum. So in min-max normalization, we use this formula. We need to apply this formula to each and every value present in your dataset. Suppose if you want to normalize these temperature values, so let's do it for temperature. X normalized for temperature of 25. So here we are applying normalized formula for this temperature column. First, we need to observe what is the minimum value and what is the maximum value in the temperature column. So when you go for the temperature column, the minimum value is 15 and the maximum value is 35. So we use these values to substitute in this formula. So normalized value for 25 is equal to, in place of x, we substitute 25 minus x minimum, which is 15, by x maximum 35 minus x minimum 15, which gives 10 divided by 20 is equal to 0.5. For 25, the normalized value is 0.5. Coming to 30, x normalized for 30 is equal to, in place of x, 30 minus x minimum 15 by x maximum 35 minus x minimum 15 is equal to 30 minus 15, 15 divided by 20. So 15 divided by 20, which gives 0.75. So 0.75 is the normalized value of that particular observation 30 in the temperature column. So like this, we can apply the normalized formula for humidity also and pressure also. So let's calculate pressure values. So the same formula we use. Before applying the formula to the pressure column, we need to find what is the minimum value in the pressure column and what is the maximum value in the pressure column. So minimum value in the pressure column is 1009 and maximum value in the pressure column is 1014. So apply the same formula for this column also. X normalized for the first value 1012 is 1012 minus minimum value 1009 by 1014 minus 1009, which gives 3 by 5 is equal to 0.6. So 0.6 is the normalized value for 1012. Coming to the second value, x normalized for 1014 is equal to 1014 minus 1009 by 1014 minus 1009 is equal to, which gives 5 by 5 is equal to 1. So the normalized value for 1014 is 1. Like this, we can calculate the rest of the values also. After calculating for all the values, we will get this table. So normalized data. For 25, we get 0.5 here. For 30, we get 0.75, 0.75. For the rest of the values, for 35, we will get 1. For 20, 0.25. For 15, 0. Like this, if you apply the same formula for the humidity column, we will get these values. For pressure column, 1012, 0.6 is the normalized value for 1012, and 1 is the normalized value for 1014. So 0.6, 1. For the rest of the values, we will get 0.2, 0.4, and 0 are the values, normalized values for this pressure column. If you observe here, all these values are between 0 and 1 only. If you apply min-max normalization on a particular data set, we will get values, normalized values from 0 to 1, where when you apply min-max normalization. So if you apply the min-max normalization, we will get normalized values between 0 and 1. So if you observe here, we will get only the values from 0 and 1 only. Like this way, a min-max normalization process normalizes the data between 0 and 1, making them into the similar scale. That means similar range of values, so that the machine learning algorithm can treat each and every column in the dataset with an equal importance. So let's implement this in a Jupyter notebook. So for this, we need to import pandas. So import pandas as PD. Also from sklearn.preprocessing import min-max scalar. So these are the required libraries to do the min-max normalization on a data set. So let's take, this is our sample data. Sample underscore data. So we need to give a floor by. So this is our sample data. First, we need to create this sample data in the form of a data frame. For this, df is equal to pd dot data frame of sample underscore data. So let's print this. So by running this chunk of code, we have to we created this sample data in the form of a data frame. So let's create an instance for the min-max scalar class from the scikit-learn.preprocessing module. Scalar is equal to min-max scalar. Okay, instance is created. So now apply the min-max normalization to the data frame. Normalized underscore data is equal to scalar dot fit underscore transform dot df. So We applied min-max normalization on this data frame. So let's print the normalized data. Before printing the normalized data, let's make them as a data frame. So normalized data df underscore normalized is equal to pd dot data frame. Columns is equal to so observe here. So this is the normalized values for these three columns original data. So let's cross check with this our calculation. See, for temperature 0.5, 0.75, 1.0, 0.25, 0.42, 0, 0.85, 1, 0.28, 0.6, 1, 0.2, 0.4. So we get the correct output. In this way, we do normalization on a original data set using min-max scalar.